In this video we will go over exercise G4 from the steel design examples according to the Canadian S1614 code, which is available for downloading on our website. By looking at the exercise, we need to determine the factor shear resistance and adequacy of an hollow steel section subjected to shear at one end, 49 kilonewtons dead load and 148 kilonewtons live load. What I'm gonna do next is to take the design load results from our analysis software, which is SFrame for this case, and use SPAT to code check this section. Now let's go and open the SFrame model that I have. As mentioned, this is a model I built before, so let's see some of its properties. We can check our section properties if we right click here and select our section. You can also take a look at the materials. We're using steel #1 material. The support conditions is fixed at one end, the cantilever. If we switch to the loads window, we can see we have a live load of 148 parallel to the depth of the section and a dead load case. We also define a load combination which represents shear under factor load value. So it's 1.25 dead load, 1.5 live load. I already run an analysis, a linear static analysis. Let's check the results in the graphical results window. We click here, and we're interested in the maximum values for moment and shear for the load combination we have defined. By looking at the shear diagram, if we go shear diagram tool, looking at the strong axis, we can see a maximum value of 283.25 kilonewtons. And please remember this value. Similarly, we check the maximum bending moment. If we click here, we can see in the strong moment axis we have a maximum value of 28.32 kilonewton meter. Please do also remember this value. With this information, we can go and open SPAT. Here is SPAT. As you can see, I need to change the design code and the steel table. You can do so if you go to Options, first Design Code, and search for the design code of interest, in this case S1614, the Canadian code. I click OK. And the steel table, again, if I go to Options, Steel Table, I should be able to find the Canadian steel database. And I click OK. Next thing I'm going to do is I'm going to find this section we're working with. If I click here where it says None, it will show me the steel sections from the Canadian database I picked. This will be a hollow section, and remember is HSS 152 by 102 by 10. So here is our section, the properties. I click OK. The first thing I'm going to do is activate this case where I will define my load combination. Actually, let's change the name. It's 1.25 dead load plus 1.5 live load. And if you remember the values from SFrame, we have a maximum moment of 28.3 kilonewton per meter, a maximum shear force in the strong axis of 283.25. You should be able to see the description of these headers if you go to Options and select Descriptive Headers. You will see more information. Now with this ready, I don't have anything else to define, and I can proceed and go and run a code check. SPAT will open this report automatically. Let's zoom in. If I go to View, Zoom by 200%, the value for cross-section area almost matches the one from the hand calculations, as well as comparing the value for VR, which is this formula here. And the difference is about 0.44%. We have a pass code check. Thank you for watching, and for more tutorials and videos, please subscribe to our YouTube channel.